Okay. So in this video, we're going to talk about how to actually solve inequalities. We're going to start with 1 and 2 step inequalities, but the process is actually the same for when we get to more complicated ones. You'll see there's not that much of a difference. So solving inequalities, like I said, it's a very similar to solving regular equations. The main difference is that if you multiply or divide both sides of the equation by a negative number, you have to flip the inequality symbol. So for example, if we have 2x is less than 12, we can treat this for the purposes of solving it just like 2x equals 12. So we would divide both sides by 2 in this case, and we're going to get x is equal to 12. Since it's an inequality, we put back in that same symbol we had before. So we get x is less than, whoops, I can't divide, 6. X is less than 6. So this one, we solve out to x is less than 6. You don't actually have to convert the symbol to an equal sign. And in fact, I would encourage you not to. But I just wanted to show that it's the exact same process to solving it. Where this gets a little bit different is if we have negative 3x is greater than 12. So if we divide both sides by negative 3, which is how we're going to solve this, we've just done this step here. So if I write this as x is greater than negative 4, what I'm saying is that any number greater than negative 4 is going to give me an answer that works. Can we all agree, hopefully, that 0 is greater than negative 4? So if I plug in 0 for x, it should solve this original inequality. If we do that, we get negative 3 times 0, which is 0, is greater than 12. 0 is not greater than 12, so this doesn't work. So this is why I actually have to flip the symbol in this case. So what I'm going to get is x is less than negative 4. So all I've done is taken the original symbol, and since I divided by a negative number, I flip it around. So this is kind of this is the only real difference between inequalities and equations, is just when you're using those negatives, you're going to end up with a lot of situations where you have to flip the symbol. The other major difference is, let's say a problem's written like this. So let's say we have 3 x, and let's say it is less than 9. If I divide both sides of this by 3, this is an equation. I could rewrite this as, so if I had 9 equals 3x, and I divide both sides by 3, I can finish this off by writing x equals 3, and I'm done. 3x divided by 3 is just x, 9 divided by 3 is 3, so ta-da, that's done. That doesn't really matter. If I do that with this one, though, if I write it as x is greater than 3, I've now switched sides. So the x was on the right before, now the x is on the left. And we can't do that with inequalities. If we do this, we can flip it around. So I could make it x is less than 3, but I shouldn't flip over where the x is in general, unless it's actually part of solving the problem. So if I had 9 is greater than 3x, the actual way I would solve this, divide by 3, divide by 3, we're gonna get 3 is greater than x, which you can write the answer like that. It doesn't matter. X can be on either side. That's fine. But if you want to, if it helps you think about it right, then you can rewrite it as x is less than 3. Just make sure that that's same, since the small side is pointing to x in this one, the small side needs to be pointing to x in this one as well. So that's another situation where you'd have to flip the symbol. Now, the easiest way to make sure that you have your symbol facing the right way after you've solved a problem is to check your answers. I wouldn't recommend doing this on all the XLs because it will take forever. But especially when you're doing this on the test, I would definitely do this every single time. It'll make sure that you get the right answers, make it a lot easier, solve all of your problems for this. You can always tell whether or not you got the answer right by doing this. So basically, because these are inequalities, they have a large range of numbers that we can pick. We don't have to just try whatever answer we get and then plug in a whole bunch of things and solve the problem out. What we can do is we can almost always pick a number that's really easy to use. So 0, 1, 10, sometimes negative 10. And you can determine whether or not your symbol's on the right side. So for example, if I solve 3x plus 7 is less than 4x minus 3, and I go minus 3x and minus 3x, so that's going to give me, 7 is less than x minus 3. We add 3 to both sides, and then we get 10 is less than x. So according to this, it says x needs to be greater than 10. So what I can do is just sub in 100 as my original problem. So if I do that, I'd have 3 times 100 plus 7, that's 307, is less than 4 times 100, that's 400 minus 3, that's 397. And this is true. 307 is less than 397. So I know that this answer works. If instead I had for some reason gotten that 10 is greater than x, what I could do is just plug in 0. So if I plug in 0 here, I would have 3 times 0, which is 0, plus 7 is less than 4 times 0, again, 0, minus 3, which is negative 3, and 7 is not less than negative 3, so we know this wouldn't work, so we would just need to flip this symbol around. So you can use either really big or really small or 0 or whatever. You can use numbers that are really easy to work with in order to check your answers really quickly in these, instead of having to plug in exactly whatever the answer you get. Now, in this case, the answer was 10, so it's not very hard to use. But if you had gotten an answer of, say, 7.5, it's probably a lot easier to use 10 or 0 to check that than it is to actually use 7.5. So yeah, again, we get x is less than 10 with that one. And so I kind of skipped over solving two-step equations because they're the exact same as they were, or two-step inequalities because they're the exact same as they were when we had equality. So let's say we have 2x plus 7 is less than or equal to 15. So the way I'd solve this is the exact same way I would do it with an equation. Subtract 7 from both sides. That leaves me with 2x is less than or equal to 8. Divide by 2. And I get x is less than or equal to 4. I don't know why I started to write it down there. And then, of course, I could graph this on a number line, just the same way that I was doing before. So again, hopefully that shouldn't be too terribly complicated. The same thing applies when you get to more complicated equations. So like if we have, like this one, for example, we have x's on both sides. We subtract 3x, add 3, and we get x is less than 10. So you solve these the exact same way you would before, or normally, for all of the different equations and inequalities. So you're just going to get some extra practice with those. You can even rewrite it with an equal sign. Just make sure to put your symbol back in when you get to the end. And use the checking the answer to check your symbol if you forgot where it goes. So main things to take away from this are, if you multiply or divide by a negative, you need to flip your symbol. And if you take x from the right side and move it to the left side of the sign, then you also need to flip the symbol. So if you have x on the right in a less than sign, it needs to be, when you move it to the left, it needs to become a greater than sign, is basically all that it is for this one. So hopefully that's not too bad. But yeah.